The Auxiliary Power International Corporation APS 3200 APU provides the aircraft with an independent source of pneumatic and electrical power which can be used during flight and ground operations. The APU is installed in a fireproof compartment located in the aircraft tail cone. Access for servicing and maintenance is provided by two doors. The APU is controlled and monitored by a full authority digital electronic control box. The ECB is located on the right side of the aft cargo compartment. It transmits the APU operational and maintenance data to the electronic centralized aircraft monitoring system. The data is displayed on the ECAM display. This is the Auxiliary Power International APS 3200 APU. It supplies the aircraft pneumatic system with compressed air for engine starting and air conditioning, and it provides the power to drive an AC electrical generator which supplies the aircraft electrical buses. All of the following component location references are clockwise from the rear looking forward. The APU is comprised of three major assemblies and their components. The major assemblies are the power section, which includes a single-stage centrifugal flow compressor, an annular reverse flow combustion chamber, a two-stage axial flow turbine, and the exhaust case. The load compressor, which comprises an impeller, a diffuser, and a row of inlet guide vanes, and the accessory gearbox. The power section drives the load compressor through a single shaft turbine. The load compressor supplies compressed air to the aircraft pneumatic system. The accessory gearbox is installed on the front flange of the load compressor case. It is driven by a quill shaft from the front of the load compressor. It provides support and gear reduction power for the accessories and serves as the oil system reservoir. Gearbox accessories. The APU generator is mounted near the 3 o'clock position on the accessory gearbox. It produces three-phase electrical power to supply the aircraft electrical buses. The control and monitoring signals are transmitted from the aircraft systems through a quick disconnect electrical connector. The generator will be removed to improve viewing access to the remaining accessories and components. The cooling fan assembly is mounted at the 12 o'clock position on the accessory gearbox. It contains a permanent magnet generator which provides the electronic control box with an interrupt DC power supply and a backup overspeed protection signal. The cooling air supply duct may be removed to provide access to the cooling fan, which may be used to turn the rotating assembly for maintenance inspections. The starter is located at the 10 o'clock position on the front of the accessory gearbox. It is operated by a 28-volt DC power supply which is controlled by the electronic control box. It is equipped with a brush wear indicator for condition monitoring. The fuel control unit is installed on the front of the accessory gearbox near the 9 o'clock position. It supplies high-pressure metered fuel for combustion and servo fuel to operate the inlet guide vane actuator and the bleed control valve. The oil pump unit is installed on the front of the accessory gearbox near the 8 o'clock position. It contains one oil supply pump and two oil scavenge pumps. Gearbox components. The oil level is monitored by the oil level sensor installed at the 3 o'clock position on the right side of the accessory gearbox. If the oil level is low, it will be indicated on the ECAM display during the start cycle. Two oil filters are installed on the front of the accessory gearbox: the engine oil supply filter and the generator oil scavenge filter. The generator oil scavenge filter is monitored by a visual clog indicator and a differential pressure switch. If the pressure increases to a specific value, The ECB transmits a maintenance message to the aircraft centralized maintenance system. The engine oil supply filter is monitored by a visual clog indicator only. The oil system is protected from overpressure by an oil pressure relief valve installed at the 6 o'clock position on the front of the accessory gearbox. The adjacent magnetic drain plug is used for oil system monitoring and maintenance operations. The oil reservoir is serviced at the left side of the APU through the gravity fuel cap or through the pressure fill and overflow connectors. A sight gauge verifies the oil quantity. The oil system deprime valve is installed at the 9 o'clock position on the accessory gearbox. It is opened during the start cycle to reduce the load on the oil supply pump and during the shutdown cycle to stop the oil flow. Oil system. The oil pump unit supplies oil to the oil bypass valve, which is installed on the front of the oil cooler. If the oil is cold, it flows through the bypass valve to the oil filter. If the oil is hot, it flows through the oil cooler to the oil filter. The oil temperature is monitored by the high oil temperature sensor installed at the 6 o'clock position on the rear of the accessory gearbox. The oil pressure is monitored by the low oil pressure switch installed on the right side of the air inlet plenum near the 3 o'clock position. The electronic control box uses temperature and pressure data for protective shutdowns during specific operating conditions. Fuel system. The fuel supply from the aircraft is delivered to the fuel control unit inlet. It is filtered by a fuel filter installed on the fuel control unit housing. The filter condition is monitored by a clog indicator. The fuel flows internally through the high-pressure pump to the fuel pressure regulator and the servo valve. The pressure pump is protected by a pressure relief valve. The fuel pressure regulator supplies servo fuel to operate the inlet guide vane actuator and the bleed control valve. The fuel control unit servo valve regulates the fuel flow to the power section. The fuel flow is controlled by the three-way solenoid valve. The servo valve and the three-way solenoid valve are controlled by the electronic control box. When the three-way solenoid valve is opened, the metered fuel is supplied to the fuel flow divider located at the 9 o'clock position on the turbine case. The flow divider distributes the fuel to the two fuel manifolds. During the initial start sequence, fuel is supplied to the three pilot injectors through the pilot injector manifold. When the fuel pressure increases to a specific value, fuel is supplied to the 6 main fuel injectors through the main injector manifold. When the APU is running, all of the fuel injectors are supplied with fuel. When the APU is stopped, the residual fuel from the fuel manifold is purged through the APU exhaust. The combustion chamber is drained through the combustion chamber drain valve installed at the 6 o'clock position on the combustion case. The drain valve is connected to the drain system manifold, which drains fluids from the air bypass plenum and the actuator and pump seal drain areas to the drain mast located at the 3 o'clock position on the right side of the APU. Air system. The air inlet plenum supplies air to the power section compressor, the load compressor, and the gearbox fan. The airflow to the power section is used for combustion, oil system pressurization, and to operate the APU compartment cooling valve. The airflow is monitored by the load compressor inlet pressure temperature sensor installed on the rear of the air inlet plenum near the 3 o'clock position. The data is used for fuel metering control. The airflow to the load compressor is controlled by a row of internal inlet guide vanes. The inlet guide vanes are operated by the inlet guide vane actuator located at the 3 o'clock position on the load compressor case. The inlet guide vane actuator is operated by servo fuel supplied from the fuel control unit pressure regulator. It is controlled by a servo valve. The actuator is connected to the operating rod by a quick release pin. The inlet guide vane position is monitored by an internal linear transducer. The load compressor discharge air pressure and temperature data is used for airflow control. The pressure is monitored by the load compressor discharge pressure sensor installed on the front of the air inlet plenum near the 3 o'clock position. The temperature is monitored by the load compressor discharge temperature sensor installed on the compressor outlet scroll. The air supply from the load compressor is controlled by the bleed control valve. The butterfly type valve is installed on the compressor outlet scroll at the 3 o'clock position. It is operated by a fuel servo actuator. The servo fuel is supplied from the fuel control unit pressure regulator and controlled by a servo valve. The bleed valve position is indicated by a visual position indicator and monitored by an internal linear transducer. The bleed control valve supplies air to the aircraft pneumatic system on demand. When the APU is shut down, it vents the unused air to the APU exhaust. Air from the plenum is ducted to the gearbox fan. The fan supplies air to the APU compartment cooling valve and to the oil cooler. Ignition system. The ignition exciter is mounted on the left side of the air inlet plenum at the 9 o'clock position. The high voltage capacitor discharge unit supplies the 2 igniter plugs through the igniter cables. The igniter plugs are installed in the combustion chamber case at the 5 and 9 o'clock positions. The ignition cycle is controlled by the electronic control box. Indicating and recording systems. The APU rotational speed is measured by 2 speed sensors. They are installed in the reduction gear case at the 4 and 7 o'clock positions. The exhaust gas temperature is measured by 2 thermocouple rakes installed in the exhaust case at the 4 and 7 o'clock positions. The speed and temperature data is monitored by the electronic control box and displayed on the ECAM display. The engine identification module is mounted on a bracket on the left side of the air inlet plenum near the 3 o'clock position. The resistor type module transmits the APU serial number to the electronic control box. Control and monitoring. The APU is controlled and monitored by a full authority digital electronic control box. The electronic control box is located on the right side of the aft cargo compartment. It records the APU serial number, the operating hours, the cycles, and other condition monitoring parameters. It serves as a maintenance interface with the aircraft central maintenance system for fault reporting and troubleshooting operations. Summary: the APU serves as an integral part of the aircraft systems. It enhances the operation of the aircraft by providing an independent source of pneumatic and electrical power which can be used in flight for emergencies or for extended range operations, and on the ground to permit the aircraft to operate independently of ground facilities and services. Some of the components that were identified are line replaceable units. Please consult the appropriate maintenance manual for additional information.